Welcome to Snap Podcast.
Hello, everyone. Welcome to another episode of the SNEV podcast. Today, I'm your host. My name is Yonis, and today we're going to be speaking about the MISEV 2023 guidelines. We have a very special guest with us today. Would you like to introduce yourself?
I'm Joshua Welsh. I'm a staff scientist at BD Biosciences in the Advanced Technology Group.
All right. Well, welcome, Joshua. Thank you for agreeing to speak with us today. As I said, this episode is mainly about the MISEV 2023 guidelines, and we have some questions that we really love to ask you. But first and foremost, we're going to start with something a bit more fun. How did you get involved in EV biology in the first place?
Completely by mistake. When I went to my undergraduate, the last year was a project for our final. It was the final year project, and we did research for the very first time. And I spent about 3 months in a platelet biologist's lab who specialized in finding platelet channels, and they were really interested in these platelet microparticles. So they started stimulating platelets with like ionomycin, and Edwin van der Pol had recently just been to the university that I was at. And at the time we were all using megmix beads and flow cytometry to look at these vesicles, we'll call them microparticles at the time. And then Edwin came along and told us all the ways we were doing it were wrong. It was one of the things I hadn't really thought about doing. Originally I'd wanted to do medicine. And then I decided I wanted to do a PhD, and then I started looking at multicolor flow cytometry, microparticle PhDs, and completely fell into it that way. I'd never even considered a PhD or even knew what a PhD was before I'd done that project. So that was completely by mistake, and it was a very deep rabbit hole I fell down.
Yeah, I always feel like the mistaken ones are always the best way to kind of fall into the topic. So what did you do after your PhD?
So my PhD, I had a bit of a strange PhD where it was meant to be in translational medicine with EVs, and pretty much at the start of it was all meant to be flow cytometry. The flow core was actually looking for a flow cytometry instrument, and none of them were really good enough for small particles. I ended up going around all of the manufacturers' kind of test sites to test instruments with the flow core manager at the time, who took me under a wing. I'm not sure why, because I didn't know anything. I was just really enthusiastic, and then somehow the Thermo Fisher rep was also incredibly kind in the UK, and they put me in contact with the R&D group in Oregon in the United States, and I had lots of naive, ambitious ideas that they put me on a phone. I was like, I want to build a flow cytometer that does X, Y, Z, and does all this stuff, and they're like, okay. Yeah, if you buy a basic a tune, we'll basically rip it apart. So I ended up turning my PhD into a kind of hardware project. I had a custom flow cytometer that was like a real Frankenstein, and inadvertently that led me down like a really interdisciplinary teaching kind of area, because although I was meant to be very much a biologist in a translational medicine group, I ended up working a lot more with the engineers and physicists, and then learning a huge amount from the engineers in the US, and I got to fly over there a couple of times. And then Jennifer Jones at the NIH was actually kind of specializing in EV sorting at the time, and I met her postdoc at a conference. She said, I'm leaving, I think you'd be a good fit for this job. And then Jennifer got in touch. And ironically, I actually met Jennifer probably 2 or 3 years earlier, and she didn't remember me, and she told me what she was doing. I was like, I'd really like to join your lab. And she kind of like, yeah, okay. So that was a strange transition. And then in Jennifer's lab, it just completely changed, because my lab at Southampton had almost no money. I think we had £5,000 or £10,000 for 3 years of research. Thermo Fisher obviously helped a lot with that, and then I went into Jennifer's lab, and she was starting up as a tenure track position, and we basically had a budget where we could buy all of the toys and do whatever we want. It was kind of like a dream position to go into, and everything was unfounded as well. So she had her own SOPs, but she was basically happy to rewrite everything. So I basically got free reign going into her lab and working with her, and that was massively. I just learned a huge amount. Like it really founded my knowledge, and even Jennifer was super keen for me to network and go to as many conferences as I needed to, and that also was really important for my career development. So yeah, I owe a huge amount to Jennifer and the NIH for that stepping stone before transitioning to industry and throwing it all away.
You can imagine there must be quite a culture shock going from Southampton to I'm guessing it's in Bethesda.
Yep. Yeah, very different. It's strange. Like NIH is an interesting place. There's a huge amount of resources there. I was going to say money, but it's probably not the right word. But it's much more of a job. Like the NIH isn't an academic research setting. It is a government position. So you work for the US government while you're there, and a lot of government jobs are safe. So you're not really going to get fired from one unless you really mess up. And that's why they also have like a lot of hiring freezes. It's actually hard to get a permanent employment there. A lot of people are contractors. But the culture is also very different. So from a researcher, a lot of people that are there as research assistants and lab managers and things, it's like less energetic, I would say, and people are more 9 to 5. They're commuting in, so they're not. When I was in Southampton, we'd finish after the day and go down the pub, or we'd go cycling and do something. And there was a lot of people around. You would have big open seating spaces. Like at NIH, everyone's kind of in their little silos and in their labs, so it's not as social. But it's it's definitely a great place to do a postdoc.
It sounds like you had a great time. How long were you there for exactly?
I was there from 2017 to 2023, so 7 years.
Oh, 8 years.
7 years.
Oh, wow. And so I had a quick look through your publication history, and it seems that you were very, very productive during your time there. We get into what you're doing now. Maybe we should go towards the MISEV2023 article that you helped to write. So one of the questions we had were, what was the motivation behind writing the latest MISEV release, and what had changed from 2018?
MISEV, why did we write MISEV? That's a great question. So I guess to back up to where we were with flow cytometry and research in general, the EV field is rapidly developing. It's very naive. I can't really think of any gold standards around anything. Acquisition of data, of isolation of samples, purification of samples, or separation, I should say, in MISEV spirit. And intrinsically, if you have rapidly evolving fields with no gold standards and we're constantly publishing, we have no ground truth. And what we think we know is constantly changing, and it also means we can't validate each other's results. So if I go and show that there's, I don't know, a cure for cancer or a biomarker for Alzheimer's, but no one else can validate it, what use is it? So we're at a point where we really need to tighten up publication requirements, or at least, like any science, we need to report things in a way that are useful to others. If no one else can use it, what's the point in publishing it? So MISEV 2018 was obviously written for a couple of years beforehand. A lot of the knowledge in that was probably limited to like 2016, 2017, for it to actually get ready for publication for 2018. We wrote MISEV for 4 years. It took longer than we anticipated because it's constantly expanding. More and more techniques are being used. We have to have arguments about what to include, what not to include. And the other thing is, when we come up with ways to standardize something, we have to debate. And ultimately, I could come up with the best method for separating EVs tomorrow, but if no one else used it or agreed with it, it's not going to catch on, and it won't be recognized as that, and it will never become a gold standard. So something that I got to learn at NIH in my postdoc was a lot of this actually stemmed from my flow cyt EV. So flow cytometry is something that I worked on for a long time. It's something I was really passionate about, and it's something where when I started, there were a lot of self-proclaimed experts. They did a standardization study, and it turned out all of the results in it were like incomprehensible. They were useless. And we spent years working out why that happened, and it resulted in reporting requirements. So we worked together to work out why we couldn't reproduce each other's data. And then we came up with a list of requirements we'd need to understand to even reproduce one another's data. And that was MyFlowSite EV. We had to argue with that and had to reach consensus with that for a long time. And a huge amount of it's like political in some ways to even get that published. Now that it's published, people can point to it and say, we need to follow MyFlowSite EV standards, and this is the reason why. But to get it over the finish line was really hard. MISEV is a route to doing that. And it's become a little bit clearer now because we have task forces to kind of do that consensus work and do the hard work, and then we integrate it into MISEV. But MISEV ultimately at its core is a consensus document. It's not necessarily what's right or wrong longitudinally, it's what's right now, what do we know right now, this is a line in the sand we draw. And there's a lot of things that just have changed. And there was a lot of things in, like the MISEV 2014 was literally about nomenclature, what do we call an EV? MISEV 2018 got a little bit more technical, and it's like, if we want to call it an exosome or a microvesicle, we need to show these proteins, or we need to do these QC steps. MISEV 2023, we wanted to take a step further, or I certainly did. When I came into it, I wanted it to be more like MyFlowSite EV, at least for characterization. For me, characterization of EVs is one of the most important things you can do, because it proves you're looking at the thing you say you're looking at. And it's probably one of the most misunderstood and misused areas is EV characterization, especially by techniques like NTA, where a lot of it is open to interpretation, and there's a lot of variables at play that we don't necessarily understand. So a lot of it came around the reason MISEV needs to be written is consensus, and we need consensus for the field to move forward so that we can reproduce each other's results is the short answer. I kind of went around in a circle on that.
No, it was very, very useful. No, thank you. You mentioned your gripes with NTA, nanoparticle tracking analysis. Those who don't know what that is, and from your background of using flow cytometry in EV research, and with the growing use of flow cytometry in EV research, what's your opinion on using NTA? Do you think it still makes sense as a method to analyze and characterize EVs?
Yeah, this could really sidetrack us, but it's difficult. So everything comes down to what you're claiming. And if I want to claim that my sample is X concentration, first off, there's no technique that can measure all EVs. Okay, so instantly, I don't know what my concentration is. I won't know if I can't measure them all. If I can't measure the full distribution of EVs, then I need to define a limit of detection. So I can say I'm measuring X number of particles per mil within this window. Okay, and that window could be multiple things depending on the technique. It might be volume, it might be what the detector settings were on an instrument. There's lots of variables in that. If I can't define those limits or those bounds, then intrinsically the measurement is flawed, right? I can't just report concentration, because if I go to someone else's instrument and they have a slightly different setup, their sample slightly different, has different properties, they will have a different concentration. We'll both be right, but the concentrations won't be right. And this is where we get discordant with data, and we can't validate each other's results. So my main gripe with NTA is that you fundamentally can't define its limits of detection, and they're variable and dynamic, so they're constantly changing. And the variables that go into even detecting them are multifactorial. So with a light scatter technique, it depends on the size, like how fast they're moving. They're going in and out of frame. It depends on the refractive index, which we're not measuring. So if you have a mixture of refractive indices and they're both the same size, some might be detected better than others. And then if there's a really broad diameter distribution in there, the big ones might be scattering too much light that they don't see the small ones. So these are all, and then there's fitting algorithms on top of it, and then there's a limit of detection, which you can't define, and then we have the volumes that we need to assume, and that's all based on camera settings. So there's just so many variables in there that make it not a reproducible, like quantitative technique when you're doing cross-platform comparisons. That said, it's very quick and easy to use, which is the draw of it. The size, the diameter distributions are almost always the same if you put any kind of EV sample in there, which I think people find reassuring. And it can be used as if I put in, like, as a workhorse instrument, if I went and did a size exclusion column, and I analysed all of the fractions from a sample that should be relatively consistent in what it contains, at least sample to sample, the relative concentrations are a useful kind of metric. So I would say it's like a quick and dirty, that it's useful, but if we're going to be precise and quantitative, that it falls apart, in my opinion.
No, I think you make a very, very valid point there. So yeah, let's get back to MSEV. And so I think there was a lot of articles that were published after the eventual publication of the MSEV 2023 guidelines. There was comments from not only just the coordinating authors, but also from the editor-in-chief of the Journal of Extracellular Vesicles. And so you guys have written extensively about the procedure behind writing the guidelines and putting things together, especially the responses that you sent out for the surveys. Could you tell us a little bit about that, like the procedure behind writing them and how you guys went about putting together all the responses that you got from the surveys you sent out?
Yeah, so the procedure to writing it was difficult. Previous MISEVs had been a lot shorter and probably less exhaustive. The way that we signed up to do MISEV was basically volunteering, and not many people volunteered to take it on, and it was a huge amount of work. It took a really significant amount of time to draft and organize that document, and it's what people didn't see. Like the surveys were definitely a key part of it, but there were probably about, I can't remember how many drafts it's written in the thing. I think there was about 17 to 20 drafts that just went through the board first. So, and that's a however many page document, and it was bigger and smaller at times. The way that it was mainly written is Deborah, Lorraine, and I were the main editors, and we kind of split the document up into the existing areas of the previous MISEVs that we wanted to update. We had discussions in general with the board, and Ken and Clotilde, who were kind of the overseers, just because they kind of passed the torch and they were checking for continuity. And they're also, very established EV researchers. We then wanted to suggest new sections. So as I said, like one of the areas really missing for me was like assay characterization. I think there was a lack of clarity for people on what they should and shouldn't report. And MISEV is a great place to build that consensus from if you're getting 1,000 people to give comments on something, and you can get people to follow a more robust protocol or controls that improves the quality of science going forward. That's a really powerful thing. So we kind of went in and voted on the areas that we felt we had expertise on to carry forward, and then we split up the document that way. And then we basically went away and we started editing those and coming up with ideas. And we had a few key opinion leaders from the board and externally. Certainly with the characterization sections, I went out and I found people that were leaders in different techniques. And then I would find another group that were also leaders, and then I would not pit them against each other, but I'd say, here's a draft, or could you draft something, and then I would send it between them so that they would kind of reach consensus themselves as leaders in that area, and that would be how it was drafted. And then areas where we kind of cut them down, because a lot of people wanted to go off on one, and they, everyone thinks their technique's the most important technique, and we need loads of details. We tried to structure, I think mine, it was 2 to 3 paragraphs, and it always had to be like a brief introduction and then details and then like reporting. So it was kind of like editing in that way. And then once that was done, obviously we sent them out. Processing comments was really hard. I had a histogram of the comment length and they ranged, anywhere from people who are literally like all good, or literally blank, to people that wrote quite literally essays. The other difficult thing is a lot of people want their publications cited. So you have to give due diligence, I guess, and look at the publications. And I actually blinded us all from who people were. You could obviously, if they put in, 10 publications and they all had the same author on there, you could work out who they were. But I felt it was best that we were blinded. And then in some cases where there was like maybe a contentious point was raised, and we weren't sure about it, then we might actually go to the author and say, actually, is this author, like an expert in this area, and we really need to pay attention to this. But yeah, processing the comments is hard. No one agrees on anything, as the survey results show, and then trying to build a concordant document that isn't contradicting itself in places is also difficult. So it was and those were processed by the people covering that section. So if I cover characterization, I would take all of the comments covering characterization. And that was why we split up areas. So I had to split all of the comments up by those as well. And then we assigned them to Deborah, Lorraine, and myself. But yeah, I don't know if that answers your question.
No, it doesn't. I guess you've kind of already answered my next question, which was what was the most challenging aspect of this particular thing, and the experiences of coordinating feedback from so many authors globally.
Partly that. There's definitely political elements to it. There's a lot of people, on the board and that really want to weigh in. The whole thing was difficult, to be honest. Like, even post acceptance and publishing, that document I think was revised another 3 or 4 times. People's names were spelt wrong, reprocessing all a reference needs to be changed. Well, the citation manager literally took like a minute to process all of the things, and then you'd have formatting errors. Like, everything was just a real pain to do, and everything was done at such a big scale that it was difficult. The other difficult thing, I think the hardest thing for me to do was turn people away from filling out the survey. So we were really tight with the survey windows, because we had to be. Like, 1,000 people responded, and if someone decided, I was away for 2 weeks and I couldn't do it, and you're like, well, we left it open for 6 weeks, and some people are like, I didn't get the email. It's really difficult to make exceptions for one person and not another, and we were quite not harsh, but we were clear, like, if you miss the deadline, I'm sorry, we can't include you. And that was really obviously disappointing for some people, especially with the second round of publication, but we felt it was the only fair way to do it. But obviously people were upset with us. So yeah, I think that was probably the more difficult part, was actually interacting with the person and disappointing them.
I can imagine that might have been a very, very difficult thing to go through. And so you mentioned this particular edition of the MISEV guidelines being a very difficult thing, mainly due to the size of the EV community and how it's grown over the years. How do you envision the future MISEV guidelines being written and constructed? And do you think we will need a document as thorough as we have now? Do you think it will be necessary in the future?
Yeah, that's a great question, and it's honestly something I don't know how it's going to go. So I think one of the key things to remember, so a lot of people have mentioned the checklist, and I've even seen people write publications and criticize that there isn't a checklist and we need to create a checklist again. So keeping in mind that MISEV 2018 has been cited thousands of times, I don't know if it's up to 10,000 yet, but it's close. Almost no one used the checklist. There's probably less than 100 publications that even use the checklist. The other really critical point is if we create a checklist and it's not mandatory and it's left open to voluntary use like it has been, no one will use it. So the other question is well, do we get editors to make it mandatory? Jan Lupau has explicitly stated that he will never make a checklist mandatory. And he's the lead editor of JEV. So if you can't get JEV's chief editor to agree to a mandatory checklist, whether all fields are mandatory or not, but just to complete it, then really there's no point considering it if the gold standard journal won't use it. So that was dropped, and that's why MISEV is more the way it is now. As far as MISEV's length, I think it has got to a length that is probably as long as it can be to be handled as a single document or a single publication, and future ones might have to, there's like 6 or 7 major sections. I think realistically those will have to be split up and maybe even be task forces that are handled separately. The difficulty there is that there won't be continuity between them. Like if someone updated the separation section tomorrow and they started using nomenclature that had come out and the nomenclature section hadn't been updated, or vice versa, that's going to be something that we need to think of. The other thing we've thought of is whether it needs to be a living document, not like Wikipedia, but like on their website. and it can be edited continuously. The only problem there is that a lot of people contribute to MISEV to get publications and citations, and it's more credible as well as a resource if it's a peer-reviewed publication, which is another area we got criticized on the previous MISEV, which is why this went through 2 rounds of peer review this time. So I honestly don't know. I really do think the board should probably be thinking now about how to handle it, because it took years to write, let alone plan, and there's a huge amount of things to consider for the next one. So yeah, I don't know, and I think it's something the community needs to think about. Whether there needs to be one, absolutely. The field is still in its infancy, in my opinion, and it's still rapidly developing.
No, I think that's a very valid response. So we're going to go back to your personal experiences as being a researcher. As we mentioned at the beginning, you've got quite a nice, extensive publication history. You published quite a lot during your PhD postdoc, and a few of us thought, oh wow, like he's done a lot. He's probably going to go off and start his own lab in the future, and kind of gave that impression that you were planning to kind of stay in academia. What kind of led you into changing direction?
Yeah, well, in short, I did plan to. I think when I was younger with my PhD, I like whatever I do, I'll aim for the top. Like I'm competitive and I want to get to the top of the chain. And when I was younger and more ambitious, I wanted to do all these big ambitious things. And then slowly, as I got into academia and went into the NIH, I realized how hard it'd actually be to achieve these dreams, or whether they were even feasible at all. Partly because of funding, how big a lab would have to be. And then there's a difference between, so I guess I'm at the age now where I would be a senior postdoc. I was a staff scientist at NIH when I left. So a lot of the people I knew coming into the field that were my age are making these transitions now to PIs, or they're going off to industry. What I've noticed with the PIs is they are very stressed, which is understandable. And the other thing to me is that they're starting to lose their edge on the thing that they used to be an expert in. And it's because they're not in the lab anymore and they're not the person at the bench and doing it. They're still an expert and they understand it, but now they're starting to delegate to their postdocs and their PhD students who are becoming those experts and becoming, the people with the technical understanding and passing the summary notes, up to the PI. And the main job of being a PI really is that you need to manage your lab and make sure that you're a good mentor. You're obviously potentially teaching on the side, and you need to write grants. And that is half the job from what I've seen for a lot of people, because funding is just so difficult now. And I really don't enjoy writing, despite the publications. I love teaching, and I like writing educational publications that I think are going to be valuable. I get something out of that. But writing grants for me is just something that you're writing something that's either accepted or not accepted, and then it has no further utility to the field or anyone else, and you spend a huge amount of time and a huge amount of pressure is put on that being good enough. It's also hugely political, as everything is. So part of the reason I wanted to stay at NIH is NIH actually give all of their PIs, they get like a base funding every year. So they get allocated positions. So maybe they'll get, 2 postdocs, 2 postbacks that are set every year. They don't need to worry about getting more funding for that. They'll probably get a research budget of, anywhere like $100,000 a year. And then there are extra little grants. You can't apply for academic grants like everyone else, but you can be co-PIs potentially with collaborators, and there's certain grants you can apply for internally. So I actually really wanted to be an NIH PI because a lot of that grant writing process pressure would be taken off. And the other thing is, I've noticed a lot of NIH PIs actually still work in the lab. Also, some of them choose to because they want to. So the part I enjoy most about science is the science, and really understanding the technical and finding solutions to things and innovating and working with technology. I don't want to be burdened with admin and writing things that maybe 2 or 3 people will read, and then it will decide whether I get funding or not. And then I think the pressure of grant writing on being able to keep your postdocs employed is another huge thing. You've essentially got someone's career in your hands if you can't continue to fund them. So I just didn't want to go down that route. And the things that I wanted to do would have required quite a big lab and a really well set up infrastructure, and it would have taken decades, I think, to even get to that level. So the flip side of that as well is just from a family and living point of view, the pay is just not good enough. Like, the world is in a difficult place right now. The prospects at NIH, I was actually in a great position and I was, fairly well paid, but I'd actually hit all of the targets that I needed to go to the top tier of staff scientist. The only thing that I didn't hit were the time I'd sat in the position. So now my ability to get promoted wasn't on my achievements. It was about how long I'd, been sat in a position, which to me is just, there's nothing to gain from that. So industry is something I've never considered. It's not something I really wanted to do. But I actually got offered a position in BD, who have like a research group that's it sits sort of outside of their other groups, and it does blue skies research to find the next 5 to 10 years of product innovation that they want to use. And if the company has, like a really difficult problem they can't solve, they come to ATG and like, hey, we have this problem. Can someone here solve it? And it's truly interdisciplinary. It's the first place. I've never really had, I can't think of the word now, where I've never really felt like intimidated by people's intelligence around me. When I moved to that group, I felt thick. And I loved it. I thought that's great. And that's something I was genuinely looking for. Like, it's really important to have loads of people around you that are smarter than you and just know different areas to it. It's not necessarily about smart. There are tons of smart people at NIH and in the lab group. It's just, we were all working on the same thing. So the breadth of expertise was a lot narrower, where I've gone into a group now where it's physicists, engineers, computer scientists. They're all, PhDs and super smart. And I feel like I don't know anything about what they're doing, but it's a huge opportunity to learn. And I've learned so much in the last year. I've really enjoyed that. And that's partly why I wanted is to be out of my comfort zone again. And that's why I was kind of lacking from just staying in a research group. And as I said, I didn't want to be a PI in academia. So it was the logical choice, and it pays more, significantly more. So even from that kind of lifestyle, when you go into industry, being in academia is like having a small business. You need to market yourself so that everyone knows who you are. You need to have good, solid publications, and then with your networking, you'll get more citations. That's also important if you want to write grants, and people, they shouldn't recognize, your papers and do it on your academic merit, but it certainly happens. We shouldn't use H-index and citations, but people are still getting employed on it. You need to play the game at the end of the day. And having the small business and promoting yourself is not like going to industry. When you go to industry, you're more part of a bigger team. It's more usually a 9-to-5 job. And that's kind of, when I say it's like a small business, it's like you can never turn off. Your work is never done. You always need more publications. You can always work out of hours. You certainly can if you want to in industry, but it is more expected that you start at 9, you finish at 5. And for me, that has been so different because I was like a workaholic. I worked at all hours. If you looked at my publications, the spike I had was COVID, because I was sat at home and I got to process all of the data that I had. So that's the year I got the most publications. So yeah, there's pros and cons to both, and it really depends on what you want to do. And there's such a breadth of industry positions as well. Going to a huge company like BD versus going to a startup is going to give you a totally different experience. Going in as like a bench scientist versus like an R&D scientist is going to give you, a different job, different responsibilities. Like it's extremely diverse. So it's hard to like recommend whether someone do one or the other. It also depends on the lab you're in and what kind of academia you want to be in. Like at NIH, I struggled to differentiate myself from my supervisor because we're already in a small field. They're like, how many EV scientists do we need in NCI? And then what are you going to do that's completely different to your supervisor? And you're like, well, everything I've learned and I'm innovating to do, I'm doing under my supervisor, but it's just difficult. Like you have to step out of their shadow as well. So I'd maybe flawed for being a PI just because I worked as a postdoc at NIH. If I'd gone away and maybe come back, it'd be easier to differentiate myself from them. But yeah. it certainly wasn't a choice that I planned to do. And it really kind of crept up on me as kind of all of my, every step of my career is, I fell into a PhD, I didn't plan to go to NIH, and I didn't plan to go to industry. They all just kind of happened.
No, I think it's a very beautiful story when it happens like that. So one of the things I noticed while we were talking was you kind of leveraged your knowledge that you had from your PhD, which was flow cytometry, to end up in the EV field. Then you kind of pushed and expanded that knowledge within an EV lab to kind of broaden and make that a more useful tool for all EV biologists all around the world, especially with the MyFlow publications. Exactly. And so one of the questions I had relating to kind of what you do now is obviously here you leverage your knowledge in EVs and flow cytometry and everything else to work for BD Biosciences, which is, I think, very famous for flow cytometry also. What would you say to people who would be in your position, who want to be in your position now, who want to make that transition from academia to industry? What kind of advice would you give to them?
It really depends what you're doing, and what you want. Like some people I imagine would want to go into maybe a position where they want a 9 to 5. Maybe they want to focus more on their personal life. They enjoy doing science. I think the funny thing is what people enjoy. So I don't massively enjoy lab work, but I love getting the data from it. So the lab work was always a bit of a chore for me to sit in a lab, do really long days to get all the samples. And then I'd meet people and they're like, I love the lab work and I hate the data analysis. So we all take different things out of it. And some people like that want to go to industry just to do the bench science every day because they enjoy like the method and, the consistency, I guess, of doing the bench work. And then they want to turn off. Other people might want to go into, more R&D positions and be innovating and creating products. It really depends what you want to do. The one thing I would say is that whatever you do, you need to really hone in on an area of expertise to differentiate yourself from everyone. Because everyone, when they list techniques, everyone says they can do everything. And there's a difference between being able to do everything and then having a technique where you know everything about it. And you should do what you enjoy, obviously, but if someone's really good at tissue culture and knows everything about tissue culture, then they're more likely to get a position where tissue culture is involved. If it's with flow cytometry, I lived and breathed for 7 or 8 years. It's not a surprise, I guess, that a flow cytometry company headhunted me. There's things along that spectrum, and they'll also guide you. And I think just being passionate about something is much harder to be competitive when you don't really have an area that you think you're really great at, or you can point to and say, look at all of these publications or these areas and prove that you're great when it comes to like a CV and interviews and stuff. And networking is the main thing as well. Like everything I've done in my publication history and things, a huge amount of them are through collaborators, and all of that was from networking. If I'd never met the people to work with them and collaborate with them, half of that stuff would have never been done. Networking is so crucial. Getting to conferences, you have to be brave and speak out so that you start to be recognized. I think that's really important. And I think, doing stuff as part of SNEV is great as an incentive and meeting people, but getting to know the researchers as well and trying to get involved more with like task forces and communities where you're going to build consensus and knowledge, and you'll learn something, but you'll also be at the edge of a field. It puts you in a position where you can become an expert or one of the experts for a given area. And I think that's really powerful for your career, whatever you want to do. It's going to help you because people are going to look to you for knowledge or help. And industry, certainly there's lots of different industries that want small particle knowledge. There's a huge amount of field. If you're an expert in small particle characterization, you don't necessarily need to stay in EVs. You could go to like a virology field or nanoparticle drug delivery. Like there's a huge amount of startups now that really need scientists that are experts in characterization of small particles.
No, definitely. No. So I think that's all the questions we had today. So thank you again, Josh, for your time. And sorry for making you talk after you're recovering from COVID. You did a great job, by the way.
Thanks. Thanks for inviting me.
Thank you very much. So to the listeners, if you are not a member of the SNEV community, it is free to join. We do have a mailing list, so please subscribe. It's completely free, and you will get email updates about all our events and podcast episodes, and also talks, which are also very, very useful. There's also networking events, which are very useful, as Joshua just mentioned. So yes, please do subscribe. And thank you again for listening, and thank you, Josh.